Hello everybody, welcome to the Gather Knowledge with Mihai channel. I'm a software engineer and I'm passionate about a lot of things, most of which I'll try to explore along with you on this channel. Today I want to discuss a programming topic and namely some interesting examples about how we can use the chrono library in C++ to make legacy code safer. The C++ chrono library has its advantages as well as disadvantages, but sometimes it can be really helpful. If you want to find out how this can help you improve your code safety, watch till the end for my proposed solutions. So without further ado, let's get into it. I'm usually compiling my C++ code using CMake, but since this is a really simple example, I will use the command line. I'm also using a formatter, clang format, which is included in VS Code as an extension to make things easier. If you don't use a formatter, you should try it at least once, as it simplifies the whole coding process so much. So let's say we have to interface with a C library, which has a function setTimeout. Usually this type of function looks something like this. Void setTimeout int timeout takes an integer and let's print it. Timeout is timeout. End line. Now, this function sets an interval for a specific task to be done. For example, we want to send a request every 10 milliseconds, or we want to run a process every 20 seconds. So now if we simply say set timeout of 10, what does that mean? Am I doing a task every 10 milliseconds? Am I sending the request every 10 seconds? Or even every 10 hours? We have literally no idea. The library might not be well documented or commented, so we might have to go to the source code, if we have it, to figure it out. Or even worse, the library might internally use some other library and we have to go to that one to find out what the function expects as input. So sometimes people just resume to trial and error, making the entire process really time consuming and error prone. So how can C++ help us in this case? The answer is simple. By using the chrono library, and more precisely the std_chrono objects such as std_chrono milliseconds as function parameter types. Std_chrono milliseconds. To specify here count. Let's compile it now and see what happens. It throws an error saying that it cannot convert an integer to a chrono type object, in this case std_chrono milliseconds. This is actually to help us. If we could convert 10 to milliseconds, why wouldn't the chrono library allow us to convert 10 to seconds, and then we would end up having the same problem as before. So how do we handle this? With chrono, we pass in the existing classes such as std_chrono milliseconds, std_chrono seconds, minutes, hours, and so on as function arguments. So we create a new object, not card traits, chrono milliseconds, timeout of 10, and we pass this into the function. Let's see what happens now. Yes, the timeout is 10. Now the power of the chrono library comes into play. If we internally use hours and the library uses milliseconds, std_chrono does the conversion automatically for us. So here, if we have hours and we want to, let's say we want to send the request every 10 hours, every 2 hours, now this conversion is done automatically. So now everything is safe. We don't have to care what's the multiplication factor to get milliseconds from hours. Same happens if we have here minutes. So let's say we have minutes, let's say we want to do the request every 15 minutes, and so happens. So the timeout is specified in milliseconds, automatically converted from what we use internally, and namely minutes. However, these conversions don't work the other way around. This means conversions from smaller units to bigger ones are not allowed. So if we have a function setTimeout hours that accepts std_chrono hours as input, for example, to start a process every hour, such as a database cleanup, it will not work. So right now we have minutes here, and we say let's pass it into the setTimeout hours, and this will not work. We cannot pass in the object of std_chrono minutes or seconds or any other unit smaller than hour to a function that accepts a std_chrono hours type object. If we look at what these objects are, they are template specialization of std_chrono duration with integers. So they internally store the number as integer. So how would it be possible to convert, let's say, 15 seconds to minutes or hours without losing precision? As a consequence, conversions are only possible from bigger measurement units to smaller ones. So now if we say here, we go back to hours and we specify 5 hours, this everything now works perfectly. Good. How can we make everything easier though? These options seem to be too verbose. We can use the chrono literals. We have to import first the namespace for them. Let's remove the old function using namespace stud literals chrono literals and set timeout here. These are a set of characters representing the measurement unit appended to a number. For example, ms for milliseconds, s for seconds, min for minutes, h for hours. Behind the curtains, the chrono literals namespace imports a series of functions that returns two chrono objects of a specific type: milliseconds, seconds, minutes, hours, etc. So the whole conversion process works again automatically via the chrono library. So now we have this set timeout here. If we say I want this to be done every 2 minutes, I can simply do it like this, and this will be automatically converted to 120,000 milliseconds for us. Same goes for 1 hour. Now here, yes. Now, these are some tips and tricks about how we can use modern C++ to improve code quality. But what can I do to legacy code or when I have to use a library written in C? I'm now rewriting all my functions in my codebase using the C++ way. This has helped me in the past to avoid all sorts of problems as they were a big source of bugs. If I cannot do that, I use wrappers. So, for example, we have a function set timeout library. Let's remove this for now. And we have a function similar to the one at the beginning, set timeout library, that accepts an integer as input, and we again just print it. Timeout is time. Now I simply create a new one. In this case, set timeout wrapper, let's say, using what was discussed in this video, the stud chrono library. It accepts a stud chrono object as input, and this function simply calls the library function for us. Set timeout library and timeout.count. What are the advantages of doing this? Let's compile this. First, I forgot to save it. No. The wrapper has to be created only once. Now nobody has to worry how to transform hours to milliseconds. Stud chrono library does this automatically for us. One person correctly listens to the documentation and that's it. The library authors usually don't change the implementations as they know that people depend on them, so the wrappers usually don't have to be changed, maybe only on library updates. Also, if I only use a function twice a year, I don't have to go every time and figure out what I should pass in. I honestly think that everybody should try to rewrite parts of their code base to make them safer using modern C++ features. We will cover more such features in future videos. Thank you for staying to the end, and I hope you learned something new. If you liked what you saw, don't forget to like and subscribe, as I will try to post stuff about interesting topics as often as possible. If you know other interesting usages for the chrono library, please let me know in the comments. Thank you very much and see you in the next video.